Okay, 1-3 is our first definition of trig functions. So they call this definition 1 of trig functions. There at the top, it says in standard position, x squared plus y squared equals r squared. Well, what is that a graph of? What's that the equation of? A circle, right? So if it's in standard position, that means that I'm centered at the origin. So I have a circle centered at the origin. Okay? That means my radius is the distance from the origin to any point on that circle. Would you agree with that? Yes, okay. That means that if I take the square root of both sides, the radius is equal to the square root of x squared plus y squared. You see where that's coming from? Yeah? You okay with that? All right. Draw your picture just in case. Here's my circle, centered at the origin. No matter where I draw it, I have my radius, right? And he's also to those points. Okay? Missed. Watch what else happens when I draw in a triangle. God bless you. What happens over here? What's this distance? Well, he would be x. And this guy would be y. So I can draw in a right triangle anywhere on this circle, and the Pythagorean Theorem works. My circle formula still exists there, and the radius is the distance from my center to any point on that circle. Kind of cool, huh? Okay, so that being said, here's where I get definition 1 from. Keeping in mind this triangle right here. Think about what you remember about sine, cosine, and tangent. It still exists. Remember that SOHCAHTOA stuff? It still works. Okay, so this part you do need to know. You will need to memorize this. Sine of theta. Okay, so here's my angle theta. Sine of theta is y over r. Think about what you remember back to SOHCAHTOA. Opposite over hypotenuse. Still exists. Cosine is x over r. Tangent is x over y. Those ones you've seen before. These ones you may not have seen before. But the reciprocals of those guys are, this guy right here stands for cosecant. Okay? Cosecant is sine's reciprocal. It's r over y. Cosine's reciprocal is secant, and he's r over x. Tangent's reciprocal is cotangent, and he's y over, or x over y, excuse me. Okay? All right, now, some things to help you. Sine's reciprocal starts with a C. S, and then C. Cosine's reciprocal is a C, and he starts with an S. Okay? Tricks to help you see the difference. Tangent and cotangent, that one kind of makes sense. Okay? You have to know this box. Alright, so it says number 1 there. For each example, find all 6 trig functions and draw a picture to help you find x, y, and r. Alright. So number 1 there says -3, 4 is on the terminal side. Okay, well where's the point -3, 4? What quadrant am I in? 2. Okay, so let's draw a picture. Here I am in quadrant 2. There's my angle. Now I'm going to draw in a right triangle. Here's the point, -3, 4. Let's label the sides of this triangle. If this is my point, -3, 4, I'm trying to zoom in as much as I can. What's this distance here? Now, it's a little crazy, but it's okay to put negatives because we put them on the coordinate plane. So this distance right here is -3. What's this distance here? +4. So r, scooting up here, is the square root of x squared plus y squared. Okay, so r is the square root of -3 squared plus 4 squared. Nine plus 16, 25. So x is -3, y is 4, r is 5. Did some of you recognize that as a 3, 4, 5 triangle? Yes, that's okay to do too. All right, now we have x, we have y, and we have r. We're just going to use this box here to fill in all 6 of our trig functions. Okay? So sine is y over r, so he would be 4 over 5. Cosine is x over r, so -3 over 5. Tangent is y over x, so 4 over -3. I don't care where your negative is. But the nice thing now about the next 3 is that they're reciprocal. So if you've got the first 3, we can just flip these guys over for cotangent, secant, and cosecant. Okay, so if I flip over cotangent, cotangent is x over y, so that guy would be -3 over 4. Secant would be 5 over -3. Like I said, I don't care what your negative is. Top, bottom, or out front. And cosecant is 5 over 4.
And the little circle, that's the O that we drew yesterday, right?
Yes, that's theta. That means our angle. So sine of my angle. Yes, good question. Questions on that first one? Okay, let's look at number 2. Number 2 says, so the first one they gave me an ordered pair, right? They gave me x and y. Number 2 says my theta, or my angle, is 45 degrees. Well, let's draw a picture. 45 degrees in quadrant 1. What's my easy point to pick on quadrant 1, 45 degrees? 1, 1, right? Don't make it too hard. If you pick anything bigger, you're reducing fractions. That's all you're doing to yourself. Okay, drawing a triangle. So this guy's 1 and this guy's 1, and he's a 45, 45, 90. So what do you know about r? Root 2, perfect. How else could you find it? X squared plus y squared equals r squared. Alright, so x is 1, y is 1, r is root 2. Bless you.
How do we know which one's x and which one's y? Is x always on the terminal side? Or, yeah,
Think about them as ordered pairs. Do what you know from ordered pairs.
Okay.
All ordered pairs are x, comma, y. Okay? Wyatt.
What does r mean as a variable?
Yeah, r is the, so go back to here. R is the, ooh, sorry, can't see my picture. R is the distance from the origin to the point. But he's also the radius. So think about him as the distance from the origin to your point. Whoops, sorry. All right, so sine. Sine is y over r. So 1 over root 2, but I gotta rationalize that bad boy. Root 2 over 2. You guys are gonna become pros at rationalizing. I skipped a step. Do I need to show it?
No.
Okay. Cosine. X over r. 1 over root 2, so he's exactly the same. Root 2 over 2. Tangent. Y over x. 1 over 1. Now we can just flip. Cotangent, 1 over 1 flips to 1 over 1, or just 1. Secant, r over x, or root 2 over 1, or just root 2. Cosecant, root 2 over 1, or just root 2. The nice thing when you do these guys, if you write it first, then you can flip this guy over. If you flip the rationalized version, you're going to have to reduce. Alrighty, let's look at number 3. Theta is 270. Where's that?
That's down.
Straight down, right? He has a special name. Does anybody remember what happens if he's on the axis? Do you remember what we call him?
Quadrantal.
Nice job looking it up. Thanks, Griffin. This guy's a quadrantal. My angle is on my axis. Okay, he terminates on my axis. He terminates on the negative part of my y-axis. Okay, so what's a nice, easy point to pick at negative 270? 0, negative 1, right? Okay, so x is 0, y is negative 1. R is the distance from that point back to the origin. How far is it back to the origin? 1. You could also do that formula right here. 1, negative 1 squared plus 0 squared equals 1 squared. Take the square root of that is still 1. Okay, let's fill in our box. Sine y over r. Negative 1 over 1, so just negative 1. Cosine x over r, so 0 over 1. If zero's on top, everything's okay. Have you seen that one? Let me show you. If zero's on top, it's okay. What if zero's on the bottom? No way. Can't do it, right?
Wow.
Like that? Okay, so what about tangent? Well, tangent is y, so negative 1 over x. Ooh, I can't do it, so we're going to write undefined. You can write undef if you want. It stands for undefined. Alright, cotangent. Flip him over, or x over y. 0 over negative 1, so that guy's just 0. Secant. R over x. 1 over 0. Oh, can't do it. No way. Undefined. X over y R over y for cosecant. So 1 over negative 1, or just negative 1. Question so far? Number 4 now gives us one of our answers. Number 4 says sine of theta is negative 5 over 13 and theta terminates in quadrant 3.
Yes.
Yowzer, right? Okay, can we fill in a box already? You bet. We've got negative 5 over 13.
The y is negative 5.
The y is negative 5, right? R is a distance. So the negative can't go with the 13. It also gives us some information that says I'm in quadrant 3. So let's draw a picture of a triangle in quadrant 3. Remember, this guy is y over r. So this guy is now negative 5. And my hypotenuse is 13. If I'm in quadrant 3, what else do you know has to be negative?
The other one.
X does. So we're going to do what in order to find x? Or how could we find x? Wyatt. Yeah, we're going to do the Pythagorean Theorem, right? When we take the square root, though, this time, we want the negative one. Okay, so here we go. X squared plus negative 5 squared equals 13 squared. X plus 25 equals 169. O squared. X squared equals 144. So x is negative 12. Now technically it's the plus or the minus, right? But it told us it was in quadrant 3. So x is negative 12, y is negative 5, and r is 13. Alright, see if you can fill in the rest of the boxes. Give it a go. Again, I don't care where your negatives are.
Go back a little bit.
You bet. Can I move it over now? Okay. Check it when you're done. Like I said, I don't care where your negatives are. Now, be mindful, though, that a negative divided by a negative is a positive. So for tangent and cotangent, I do want those to be positive. Okay? All right, you ready to try 5? All right, so number 5 says cosine of theta is 24 over 25 and terminates in quadrant 4. So now we've got some other information. Now we're in quadrant 4. Well, we know that cosine is x over r. So I'm going to draw me a graph in quadrant 4. Draw my triangle in. Alright, so my x is 24. My r is 25. What do you know about y in quadrant 4? It has to be negative. Okay, so I've got x is 24. I don't know why yet, but he better be negative, and r is 25. Guess what? It's your most favorite thing. We've done it a million times. We're going to do it a million more. Pythagorean Theorem. All right, so 24 squared. 576 plus y squared equals 25 squared, 625. So y squared is 625 minus 576, 49. So y is technically plus or minus 7, but I want the negative one because it told me it was in quadrant 4. Okay, so here we go. We've got 24 over 25. We knew that for cosine. They told us that one. So sine, y over r, negative 7 over 25. Cosine, they told us, tangent, y over x, negative 7 over 24. And now we can flip. 24 over negative 7. 25 over 24, 25 over negative 7. Why?
Why do we get all those?
Why do we have to do cotangent, secant, and cosecant?
Yeah.
Because that's how we find all 6 trig functions. When we get to the end of this chapter, we're going to use those reciprocals. We need to know the reciprocals so that we can solve identities and things like that. Yeah. Okay, I want you to just look at this chart for a second, and we're going to make some, look at what we've got going on. So in number 1, he was in quadrant 2. Right? Number 2, he was in quadrant 1. Number 3, he was on a quadrantal. Number 4, he was in quadrant 3. Number 5, he was in quadrant 4. So we've done an angle in each one of the 4 quadrants. Would you agree with that? All right, so look there. Let's look at the guy with quadrant 1. Number 2. When I'm in quadrant 1, what are my ordered pairs? We talked about this on Monday. My ordered pairs are plus, plus, right? Which of those 6 trig functions are positive in quadrant 1? How many of your answers were positive? All of them were. Okay, look at quadrant 2. Number 1. Who's positive in quadrant, or wait a second, what are my ordered pairs? Negative, positive, right? So my x's are negative. Who or which trig functions are positive, or do you get positive answers in number 1? Which ones were positive? Yeah, sine and cosecant. That is always the case. Sine and its reciprocal. Okay, quadrant 3. We're looking at number 4. What are your ordered pairs in quadrant 3? Negative, negative. Look at your answers here for number 3. Which one was positive? Tangent and its reciprocal, cotangent. All right, last one, quadrant 4. What are your ordered pairs? Plus and minus, right? So look at number 5. Who was positive in quadrant 4? Cosine and secant, its reciprocal. If you didn't write this chart down, you might want to put that in a nice pretty place in your notes because it's very useful. In fact, I have a little acronym for you to remember it. You ready? All students take chemistry. That tells you which of the 3 functions, and its reciprocal is positive in which quadrant. All of them are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. And cosine and its reciprocal secant are positive in quadrant 4. That's because of those x's and y's. Okay? X is positive, y is positive, everybody's going to be positive. Sine is with my y value. So that means he's got to be positive. Tangent. They're both negative. The only way to get a positive is take x and y and divide them. So that's why tangent's positive. Cosine is tied to my x value, and that's the one that's positive in quadrant 4. Like I said, if you haven't written this down on your notes, I'd put it somewhere. You're going to want to, it's kind of useful. Questions? Okay, we got one more to do. Number 6 says the terminal side of theta lies along the line y equals 5x. Wow, that didn't come out right. 5x. If it doesn't tell you, assume quadrant 1. Okay, so let me think about the line y equals 5x. I graphed a little line here. So if I start at 0, 0, and my slope is 5, up 5, 1, 2, 3, 4, 5, over 1. And Griffin, I think you just said it. There's my itty bitty triangle.
1 and 5.
1 and 5. So x is 1.
25 plus 1 is 26.
Yep.
26 is
R is the square root of 1 squared plus 5 squared. 1 plus 25. Root 26. Alright, so sine y over r. 5 over root 26. Ooh, that looks nasty. Rationalize 5 root 26 over 26.
5 root 26 over.
Cosine x over r. So 1 over root 26. So root 26 over 26, or 1 root 26, I don't care. Tangent y over x. 5 over 1 or just 5? Flip them, 1/5. Square root of 26 over 1 or just root 26? Square root of 26 over 5. Whoa, hey, sorry about that. So, let me zoom out so I can show you something. So what did we do? First of all, we drew a triangle for each one of them. Notice that I drew a picture for every single one. That makes it a whole lot easier. I listed out what x, y, and r are. That makes it a whole lot easier. Also, after doing this for very many years, I know my x, y's, and r's, right? But put that in your memory bank. Memorize it. It'll make your life so much easier, I promise. Okay, so keep your little handy, make a note card, whatever you need to do, so that you know that sine is y over r. Cosine, x over r. Tangent, y over x. Okay, bless you. All right, questions, other questions.